Hello friends, today we are going to see about our next lecture of photochemistry. So in this lecture we are going to study about Barton reaction. Let's see in detail about Barton reaction. So Barton reaction that involves the photolysis of an alkyl halide to form a delta nitro alcohol. The Barton reaction involves a homolytic RNO cleavage. The Barton reaction involves a homolytic RONO cleavage. Here you can see RONO cleavage. Suppose this is R group, RO and NO cleavage. The homolytic fission of this bond. So Barton reaction involves the homolytic RONO bond cleavage followed by delta hydrogen abstraction. So after cleavage of this bond, because of photolysis, after cleavage of this bond, oxygen will contain the oxygen radical and an O radical is get separated. So this oxygen radical will abstract delta hydrogen. So count alpha, beta, gamma and delta. Hydrogen on delta position is delta hydrogen. So this oxygen radical will abstract this delta hydrogen. Now this hydrogen will shift on this oxygen with a six-member transition radical transition state. So the free radical recombination and tautomerization will be there. This carbon radical recombines with this nitrosyl radical. Okay, so new bond formed between this carbon and nitrogen radical. You will get, which gives the resultant nitro compound. So which undergo tautomerization. So delta nitro alpha beta gamma delta nitro compound of alcohol. So which on tautomerization you will get oxime. So see deeply with one example. See, in this compound you can see here is our nitrosyl compound. After breakdown of this bond, nitrogen oxygen bond, you will get a nitrosyl radical and oxygen radical. So this oxygen radical will abstract the delta hydrogen. Alpha, beta, gamma and delta. Delta hydrogen will abstracted by this oxygen. So in next step, here will be a radical on this carbon. So here is the radical and this radical again recombine with this nitrosyl radical. Now the new bond formed between this carbon and this nitrogen. So here is the nitrosyl compound. So finally you will get a oxime after a tautomerization. Okay, let's see one example. Here we have alcohol, simple alcohol. Now with nitrosyl chloride, that is our first step. With nitrosyl chloride, we will get a nitrosyl compound. Okay, this is our substrate for the Barton reaction. So after H nu, in presence of H nu, you will get firstly breaking of this bond, will get oxygen radical. Then this oxygen radical will abstract hydrogen from delta position. Now count the delta position: alpha, beta, gamma and delta. So this hydrogen present on this carbon will abstracted by this oxygen. So here will be oxygen and hydrogen bond formation. So OH, in next step there is OH and this carbon radical. There will be formation of this carbon radical. So this carbon radical will abstract this separated nitrosyl compound, nitrosyl group. So this NO will be shifted on this. So here nitrosyl group on this carbon. Okay. Now in second step tautomerization and finally on hydrolysis you can also get a aldehyde. Okay. Let's see one example. It is important reaction for the synthesis of many natural products. So aldosterone acetate, corticosterone acetate reacts with the nitrosyl chloride in a dry pyridine. So nitrosyl chloride in a dry pyridine, it yields nitrile. So this is our first step, that is yield of nitrile, which is our substrate for the Barton reaction. First step. So this nitrile when we use in photolysis, after photolysis it will gives you oxygen radical bond breaking. This bond will be break. So nitrosyl radical will be separated and oxygen radical will be there. So this oxygen radical will abstract hydrogen from this CH3. So alpha, beta, gamma and delta. So delta CH3 ग्रुप आहे त्याच्यावरचा हायड्रोजन हा जो ऑक्सिजन रॅडिकल आहे तो ऍब्स्ट्रॅक्ट करणार. ओके, आणि हा जो नायट्रोसिल ग्रुप आहे तो बाहेर पडणार आहे. दुसऱ्या स्टेपला काय होणार की ऑक्सिजन हायड्रोजन होणार आणि इथे रॅडिकल फॉर्म होईल. तो रॅडिकल काय करणार, बाहेर पडलेला नायट्रोसिल ग्रुप स्ट्रॅक करणार आणि नवीन बॉन्ड फॉर्म होणार या कार्बन रॅडिकल मध्ये आणि नायट्रोसिल रॅडिकल मध्ये. सो फायनली नेक्स्ट स्टेप आहे तशाच पुन्हा काय होणार, टॉटोमरायझेशन होणार आणि त्याच्यानंतर याचं काय होणार, अल्कोहोलचं पुन्हा ऑक्झाईम फॉर्म होणार, नायट्रोसिल ग्रुप पासून ऑक्झाईम फॉर्म होणार. फायनली नेक्स्ट स्टेप मध्ये अगेन पुढच्या स्टेप म्हणून NO2 रिएक्शन, सोडियम नायट्रेट बरोबर रिएक्शन केल्यावर तुम्हाला फायनली जो डिझायर प्रोडक्ट आहे दॅट इज हेमी ॲसिटाल तो आपल्याला मिळतो. सो दिस हेमी ॲसिटाल प्लेज मेन रोल इन क्युअरिंग लो ब्लड प्रेशर. मग तो लो ब्लड प्रेशर जर असेल तर त्याला नॅचरली नॉर्मल ब्लड प्रेशर करण्यासाठी मग हेमी ॲसिटाल यूज होतं बॉडीमध्ये. You see the next example. Next example is synthesis of azadiradio. So in this, there are few steps for the formation, and our interesting compound is this. Okay, from this we are going to form azadiradio, which is the most important compound because it is effective against inflammation, peptic ulcer, mycobacteria, diabetes, cancer, malaria, and more things. Means along with the other activities like bone cell differentiation as well as antifungal activity, etc., etc. So it is I can say, very important compound. So nitrosyl sulfuric acid we are using here for the formation of azadiradio. In last example, we were using nitrosyl chloride only. So in this example, they use nitrosyl sulfuric acid. So you can see there are few steps. So important compound is this. After reaction with nitrosyl sulfuric acid in presence of a pyridine, so nitrosyl sulfuric acid gives formation of bond between oxygen and nitrogen here. So here is the formation between bond between oxygen and NO. So nitrosyl group attached at this carbon atom, or sorry, this oxygen atom. So after the photolysis, the bond between this oxygen and nitrogen will break down. Now you can see you will get this OH as it is, and at alpha, beta, gamma, delta. At delta position there is a nitrosyl group rearrangement takes place. Now in second step there is a formation of oxime compound, and finally after few steps final compound that is azadiradio formation takes place. So these two are important examples, and many more examples are present on net, so you can also refer that. I have used some references. So thank you for this lecture. In next lecture we will see photophorese rearrangement. So thank you.